Hello and welcome everyone to this DBA Masterclass. My name is Osama Ahmad, EMEA Data Management Business Development Leader. In the past, we told you that we are focusing on 23C over this period of time, and today we decided to continue with that trend. And therefore, we selected the topic of 23C in new features for Oracle Scalability, high availability, and disaster recovery, which is quite an important topic for DBAs and data management professionals, as well as IT service managers and architects. And in order to tell you about it, we are joined by Anil Nair. He's a product manager of Oracle Mission Critical Database Development. Anil joined us in the past to cover topics on DBA Masterclass related to high availability and Oracle RAC, and today he is going to cover the full spectrum. I'm also joined by Stefan Duprat and Jesus Robles from the EMEA database specialist team, and they will be answering your questions in the Q&A. So as usual, if you have any questions, please post them to the Q&A window and the team will attend to them. And if you'd like to stay informed on what's going on with DBA Masterclass on LinkedIn, then you can join our LinkedIn channel if you have not done this in the past. So we usually inform you about the upcoming sessions and also share some resources or some updates on the past ones. And here are a number of resources which I will share with you as well, where after today's session you can go to find more information. I will also share an extended list of resources that may include some blogs and videos on our LinkedIn group in 1 or 2 days as well. So with that, I'm going to hand over to Anil. Anil, over to you.
Great. Thank you so much, Osama. So I'm going to start sharing now. I hope I get the right screen. And with that, I hope you guys can see the screen.
Yes,
all right.
Yep.
Perfect. All right. So welcome everybody to the session on what's new in 23C with Oracle Scalability, high availability, and disaster recovery. Quite a mouthful, but a lot of important features that go into each of these categories. Today's theme is essentially, all of these features. We want to make sure that it's easily accessible, as in easily consumable for DBAs. Integrated, like you don't have to choose one over the other. Obviously, it wants to be reliable, and we want it to be massively scalable. Okay, so I'm Anil Nair. I'm the product manager for Oracle Real Application Clusters, ASM, App Continuity. I have a lot of other things are associated around the whole scalability and availability scenario. If you, I'll talk about a lot of the features. Sometimes I'll go over them, assuming that people know some of those topics. Like, for example, if I talk about, Buddy, Recovery Buddy, and all that, they're all, already explained in my LinkedIn, blogs, and a lot of my material that I presented earlier is in SlideShare. So if you want to take a look at it, you can, check it out. Or of course, you can always feel free to reach out to me on social media. I try to be at least within 24 hours provide a response. Having said that, let's jump into this, right? So Oracle has had a lot of tools and capabilities for HA. The point is, one of the main things that we have tried to focus on is that access to them should not be an afterthought. What do you mean by that? Well, because today data is growing almost exponentially, right? Back in the day, like 5 years ago, 10 years ago, having hundreds of gigabyte was supposed to be big, and now that's considered not even that big of a database, right? That's what is called as a data sprawl. Data can come from different sources, and it kind of should not be thought like, oh yeah, we have this petabytes of data. Now we need to think about how do you protect that data, because that data is important. A customer in a call other day said they were showing an application to me, and I was like, okay, how important is an application? They actually had a dollar amount associated to that application, something like $85 billion for that application, right? So imagine if that data goes away, they lose that much money. So that's not a thing that should happen, right? So you want to plan that. And you don't also want to have oh, if I have to use this, I have to change my entire infrastructure. You want to make sure that you have it in a way that is easily consumable. The second thing is most of the people think like our competitive vendors think like, oh yeah, let's put some into that database, some into this, and then we'll have a query that we can, join from these different disparate data sources and respond to, the user events. That's not very efficient, because what happens if some database is down or some data is not, available at that time? How does that query respond? Does it give partial data, or does it give, incorrect data? We recommend, obviously, Oracle has a lot of features. The Converge database provides you a lot of choices in like how do you use or consume the data, and then built in HA. So you don't have to start with, say, RAC. You can very well start with single instance and add one node if you want later, and then add 4 more nodes as your data grows. Similarly for storage, right? ASM allows you to add disks and disk groups so that you can easily scale. This reduces costly sprawls and also reduces your capex, because you start with a smaller footprint and grow as you want. So yes, we have all these options. How do you consume it? Well, we can really provide you a plethora of options, as you can see, right? From the left-hand side, you have standardized deployments. For example, if you have taken a look at the new ship home-based installer that we have, the gold image-based installer as you have, it's amazing that you can actually deploy once, create a gold image, and then deploy it hundreds of times again and again. We also have VM templates for the longest time. And for engineered systems, we have all our automation that, you go define your IP addresses, you define your requirements, and then boom, the deployment would go and create all your VMs, all your databases in one shot. We also have something called as fleet provisioning and patching. So if you have a requirement to patch a fleet of database servers, you can add on things like you could patch single instance, you could patch RAC, you can patch engineered systems. You can also have your own custom patching scripts. So you have things that can take care of that. You also have automated containerized deployments. This is the problem that customers face when they have their application team. I don't want to know about RAC. I just want to make sure that I have my application. I can connect it quickly to some container that is running RAC. Well, guess what? We have that. We have a provision to do that. And same thing for OpenStack. And we have not just in the on-premises, we also have this in the cloud, in our cloud-based deployments. For example, all of our deployments like BaseDB, Exadata, regardless of its clouded customer or cloud services, autonomous, all of these automatically, you can benefit from all the HA features just by having a simplified, standardized deployment. So let's talk about one of the main things that is coming out in 23C, which is the containerized Oracle RAC on Kubernetes. So we started our journey for a while. Since 19C, we started with Docker, and obviously with all those issues going on with Docker, Docker became more of a Podman became more of a standard. So now Podman is the new thing, but obviously we support both. We also have what we call as the RAC on Kubernetes. So RAC on Kubernetes you can consume by support. There is there from the Oracle Linux cloud native environment with 23C, and the support for the Aura operator is coming up very quickly. So it should be out very shortly. Now this gives much easier access right from the base, right? If you have a developer who's wanting to look at, hey, how do I, what is different? I want to make sure I can write some application that takes all the capabilities and features available in RAC right from the get-go. Sure, you can do that. The second part about availability is that we want to give you is how do you consume it even faster? So one of the projects that was worked around in 23C, one of the things that you may not hear many people talk about is how can we make deploying GI faster? So we went through all the GI libraries, the files, the binaries, and we reduced that. We thought, okay, we don't need this, let's remove it. And we tried to make them so small. So now if you look at a 23C GI, it's like half the size of a previous releases. And I keep saying previous releases because we also took the same thing and backported some of this to 19.20, 19.19, various releases. That's why my example is showing you a little bit older 1915, just to show you that the comparison. But if you look apples to apples today, it might not give you exactly, because a lot of those we backported into older 19C releases, right? The latest RUs in. And also, obviously, because of this, it's half the size. We also added optimization to deploy it faster, so more faster copying. So that means you can, 2x times faster to unzip and copy to different nodes. What does that mean? That means is, that operations, the typical traditional operations like installing, adding node, deleting node is like faster. Like I was looking at some numbers that yesterday, we can actually do a whole add node operation if you obviously templatize and script it, like less than 3 minutes. That's amazing numbers, right? So you want to make sure that you want to do more and more of these things automated. So if you take the time out, we have broken this out into what is that time being spent on. If you see that most of the time we still have to do the pre-install check, the install and copy is very less, and the run root scripts is there and post checks. So again, we are continuing to work more and more to reduce the time it takes to go and deploy GI and get a ready-made database for you. Once you have a database, what is the second thing that you need to do? Well, you create services. Like a lot of you may not be talking and dealing with thousands and thousands of services, but we do, right? If you looked at autonomous, if you looked at various of our offerings, there is a lot of services. And what happens when you have a lot of services is that we found out that, hey, if you create like 10, 20, 30, 50, 100 services, maybe, performance is good. But if you have to say create 10,000 services, and we found out that yes, we are taking time, so we went ahead and improved that algorithm. So now we can do 8x times faster to create up 10,000 services. And more importantly, let's say you want to delete or modify the 9,935th service, accessing that service is now 14x faster. So all of these numbers are trying to tell you that yes, we give you access to HA faster, and you can also put a lot more on these databases, like services, the number of services, the manageability of those services. We're making it simply easier. The bit complicated part about Oracle RAC or Oracle Scalability offerings is we give you a choice of what you want to do. So you have on the left-hand side RAC, you have what we call as ADG or Active Data Guard. You could do read replicas or Golden Gate, or you have what we call our globally distributed database. But the best part is on the right-hand side. You can choose any combination. It's not a and or, it's not an or decision, it's an and decision. So you could use RAC with Active Data Guard, and we'll talk about some use cases. We'll talk RAC with globally distributed database. I have a use case for that. So we have a choice that customers can, think about what they need and get all these technologies to work together. Remember, it's not just working together as in minimal. We actually are tightly integrated. And we'll talk about that in one of the examples I'll provide. So this is on the left-hand side is a global payment processor, and one of the things they implemented is as you can see, they have a two-node instance rack, they have a primary, they have a standby, and this was great. This was great globally; it worked fine. And then somewhere around 7 or 6 years ago, there was this problem that, or not problem, basically the as they expanded into different geographies, some of the countries and some of the continents, they had this requirement of no, our data should not leave our country or our borders or our continent or whatever. And so we found out that that is an ongoing threat, right? In the sense of how can you get all the data back to the US with this technology, the same thing. So what did we do? We didn't have to re-architect anything. If you see on the right-hand side, all we did is we created extra shards. So now you're using a combination of RAC and sharding, so that the data in India is staying in India and the data in the US is staying in US. We don't, replicate the data, but because of this feature, we can simply add on. Now think about it. Now, if some other country wants to do the same thing, we can simply add on those shards. So you get the best of both. Each of these shards, even in the local countries, are running with rack. So you can have 2 shards or 3 shards or 3-node rack for those shards, and then amazingly, you can use the same application, no changes, nothing, because it kind of is able to scale. This is kind of the best of both. Now you'd say, hey, how does routing work? Remember GDS? GDS makes it so much easier to define once. So a query or a service or a connection that uses a service requires data from the US or is accessing data from the US, the GDS will route it to the US. And GDS, if it is from the India, will route it to India-based center. So as you can see, it's so much easier to just add on instead of replacing and re-architecting the entire solution. Pluggable database integration. As you know, with 23C, pluggable database, or as I call it, the CDB or container database, is the only option. So we have started this journey way, way long back, as in integrating with RAC, integrating with services. So we continue this journey. So for pluggable databases, we want to simplify lifecycle management, right? Obviously, we have ways by which pluggable databases can be started or opened. Actually, that is the right technical word. Pluggable databases are opened on either all the nodes or a subset of the nodes. And we provide you various options. For example, you have a uniform service or a singleton service. We also provide you an option to unplug and plug into somewhere else. So you could take a PDB, you could create a clone for testing, because you say you have some specific data that you want your application to test. Yeah, sure, you can clone it. You can incrementally refresh it. Okay, so that's even amazing. And then finally, when it's ready, you can even put it back in production, and you can upgrade using a plug and unplug plug. So all of these things, and this all works together with the services, integrated with everything. So if you have created a service for a PDB, the service will define where the connections would be going, if depending on where that PDB is open. So a customer or a DBA does not have to do more than just follow these lifecycle management operations, and the connections will follow wherever the PDB is, wherever the service is. So this is so amazing that we don't just have an option. We kind of make sure it's very tightly integrated. Obviously, all of our features like globally distributed database, RAC, RAC1 node, or active data guard, they all use or consume PDB. So you can actually have, as you can see on the left-hand side, the shards can be pluggable databases in different CDBs. That's amazing. With RAC, we provided you a new feature, which I talked about in the past, which is called as PDB resource modeling. So what is that? So remember, I told you the story about 10,000 services. Now, one of the problems with 10,000 services is, hey, who starts up first? Before this feature, we start services based on the way they are defined. So if you have hundreds of services, we'll define them 1, 2, 3, 4, and then we'll start them 1, 2, 3, 4. Now you may say, no, I don't want that. I want my 50th service to be starting first, because that's my most critical service. Sure, you can define that. So you can define rank by via DBCA or via servctl modify, or we give you various options how to define it. Once you define it, we respect that. So when you say that, hey, service number or PDB number 50th or service 50th is the one that I need you to open first, sure, we'll make sure we'll follow that. So all this resource modeling and all these optimizations are there for you for RAC and RAC1 node. On the right-hand side, active data guard, we can provide you read replicas. We also provide you something which is called as data guard per pluggable database, and I talk about it in the subsequent slide. As part of the way to automate and improve, we try to first of all, RAC, we try to reduce the chances of databases have to be restarted. So we try to do more and more online operations, and I'm going to talk about a couple of features that even help in that. But let's say if you need to start up your instance, and therefore excuse me. So let's say you need to start up your database and PDBs have to be open, and you have hundreds and hundreds of PDBs. Well, we are already making, we are working on that. Compared to 19C, we are about 2x time faster to open a PDB in 23C, and the same thing on the as you have more and more PDBs. So how do we do that? We do this because we open in parallel with DLM reconfiguration. What that means is, in the past, the DLM reconfiguration was at a database level. So remember, we had all this, reconfiguration which need to be sent, messages which need to be sent across all the instances. Now what we are doing is, let's say you have PDB is open only on one instance, the reconfiguration can be confined to only those instances where the PDB is going to be opened. So we kind of make it much more faster and even reduce the number of messages that we have to send in a large cluster. So that some of the optimizations, I'm going to, I can explain a bit more about is reducing the scope of where messages are being sent, depending on where the PDB or service is going to be opened, drastically improves the open times for a PDB. Second part, how about data guard per pluggable database? This we introduced somewhat in 21C. I would still say 23C is where a lot of it is much more easier to consume. So what that means is, if you look at the diagram, you have a primary CDB, and then you have a primary CDB on the right-hand side too. What that means is basically you have a data guard, but it's kind of like the source PDB, the one on the red PDB on the left-hand side is actually having a data guard environment on the right-hand side, and similarly the blue one is having it crisscross. So this way you can actually have a kind of like a active protection. So this is something that is really, you can scale up to hundreds and hundreds of PDBs. You can deploy it in any way you want. Like in this case, you can have some PDBs that are unprotected, and that's perfectly fine. This allows you to deploy with the container database architecture without having to worry. For example, without this feature, let's say if this unprotected PDB, we are forced to protect it because this protection is done at this layer, the CDB layer. Now with this feature, we can actually protect it at a more granular level, but still benefit from having all of these in the same container. Okay. With 23C, you have basically these features like real-time query for DGPDB configurations and DML redirect. So DML redirect allows you to insert into in this case, you would actually call it, doesn't matter where you're connected. If you're inserting into the red PDB and the connection is going to the target PDB, we'll resend it back to the source PDB, do the insert, and apply the changes and let the application know that the transaction has been completed. So yes, we have all these features for making sure that the database code doesn't go down. But thanks to your feedback, we have found out that plant maintenance is one of the main concerns, main things that as you DBAs or data managers, database managers, or application developers are telling us. How do we know this? Well, we run this what we call as the Oracle RAC summits or the MAA summits, and we ask the customer, what are your main pain points? And all the time, this is very common. We typically hear that patching and upgrades are the main thing. So if you look at it, you're almost like more than 55% is, this. What is the problem? Like, and again, I keep saying this because although 32 and 24 seems big enough, the rest of all of those are affected. Like HA is affected because of that. All of these things are affected because of patching and upgrades. So let's learn about what we are trying to do to help reduce your pain points. Okay. So let's see what we have right now. Right. So we have this concept of rolling updates, or RUs are rolling up, you can apply RUs in a rolling fashion. So we try to reduce, what we call as, we try to reduce the downtime. So if you have a RAC or RAC1 node, we can apply patches in, you basically take servctl, relocate the sessions, go to the other node, apply the patch, and then you fail back if you want to. This is very easy with RAC, one node and RAC. So that kind of makes it easier. With Active Data Guard, yes, there is some of with what all these options we have, like Data Guard, Golden Gate, or GDD, we can make sure that you confine that to a subset of the like, for example, in Active Data Guard with 4 nodes, you can apply that in each node, or in Active Data Guard single instance mode, you apply it on the standby first, and then you can apply it on the primary. So we have all of these options. The main thing, again, one of the main things, even after my colleague Mike Dietrich has been talking about this for the longest time, is understand the difference between updates and upgrades. It's easy to confuse both of them. A lot of the times I look at some queries that are coming from customers mixing up upgrades versus updates. Upgrades are when you are moving from, say, a 19 to 23C. Updates are from when you apply 19.19 or 19.21 or 19.22. So there are a lot of these options that you need to understand, and there are a lot of specifics about these upgrade versus updates. So, for example, I already talked about something which is called as the if you are having active data guard, you can apply using the standby first. This makes it easier, and there is a lot of MOS nodes. We have automated this in FPP and other automation. And some of the Oracle customers, ACEs that I talk to, they tell me yes, they have written Ansible scripts for automating this. Great. This is available, and this works, and we have seen customers use it. On to cases where you're doing upgrades, right? You have a choice to use DBMS rolling, and I talk a little bit about it. But basically, what you do is you have a standby, you convert it to from physical standby to a logical standby, or you call it transient logical standby. You do the apply all the updates, you upgrade it, and then you continue where you left off, where you stopped your application, and then convert it back into the standby and open it up as a new primary. Yes, it involves a lot of steps. Again, that is something that you can script it and make sure that it's automatically doing end-to-end. FPP allows you to do that. MOS nodes are there as referred there. What happened for technology refreshes? What is technology refresh? Well, what happens if you are having a lease on a hardware and you want to replace the hardware? Well, you don't have to copy or do all the things during downtime. You could actually create a standby on this new hardware and then do a switch over. You could also do add node. Then you're easy. And what that means is you're online. When you're doing this add node operation, add instance operation, your applications are continuing. Yes, there may be some performance thing because you're copying, literally gigs and gigs of data, and depending on your storage and all that, there may be something, but you're not down. You don't have to start maintenance, take it down, do this and all that. So a lot of these options we are providing you to make sure that you can consume patches, upgrades, or even technology refreshes all without having any downtime. If you haven't heard of this term called AC or application continuity, I'll talk a little bit about it at the end. But transparent application continuity now has DBMS rolling support. What does this mean? Well, to just explain what application continuity is essentially we have had the feature where a session can fail over to another instance if the session is connected to, if the instance which the session is connected to has crashed or went down or something. Much easier, right? You connect and it fails and you go to the other one. Perfect. TAC tries to make sure that not only fail over, but you continue off where you left. And I'll explain a lot more details later. But for the context of this, you can use DBMS rolling to, for example, do your upgrade. So on the left-hand side, you have a 19C database. And then right-hand side, you intend to end into 23C. So same thing, as I said, the prod, you're applying redo. You stop the redo, apply. You convert that to the logical standby. You upgrade it, you continue your apply because whatever was stopped, you continue your apply. So now that standby is up to date with whatever changes that went on. And then you do a switchover whenever you want. And when you do the switchover, you can do it in a planned fashion using draining. What is draining? Draining is the feature by which you can actually move sessions in batches in a way, if you think about it. So let's think that you have 100,000, database applications, and you have thousands and thousands of sessions. By doing a draining, kind of let the application session know that you have to move to the other side. Other side being, in this case, on the 23C. So if an application is between a transaction, it can wait and finish the transaction, then move over. But the point is, instead of just taking 1,000 and moving them on the right-hand side and causing unnecessary performance overhead on the 23C, we kind of move it in a orderly fashion. So that makes it so much easier, and that the application doesn't see the impact of this. Right. So this is amazing that we have integrated all the technologies, the data guard technology, the application continuity technology, and if this prod and standby is on rack, yes, they all work together so that you get the least downtime. You actually have no downtime if you follow this. But I understand when you do a switchover and all that, you have some time when the database applications are connected from the standby, or old primary to the new prod. So caches and all those things need to be updated. I talk about caches, that's why I left that hook there. So I will come to that caches part again. With the AC, one of the things we want to help out is to do what we call as database initiated planned failover. So let the database determine when's the best time to failover. So typically, if you think about plant maintenance today, the most common thing that I've heard about is you decide on, okay, this Friday, we're going to be applying this patch. We're going to move sessions over. We're going to stop everything. And then you send out this email blast or Slack messages or whatever saying, hey, plan downtime. We want to make sure we can do better than that. So what we want to do is we let the database decide when should a session move. So remember back, I have presented on this topic where when you say that, okay, instance one is going to go down, or if it has gone down for any reason, as shown there, we want to make sure that we, tell the upper layers that this is happening. And we do this with fan, right? So we tell the upper layers with fan that, hey, don't even think about sending anything on instance once because it's not there or it's going down or whatever. This is important. You say, yeah, but what's the big deal? I have a scan entry in my thing. So if the instance is down, what does it matter? Well, it matters because if you have an application server that is using some kind of application pools or connection pools, so what happens is the connection pool is pre-updated with certain connections. So now we have, because the instance went down, certain sessions that are kind of stale. So having a fan to that makes it much easier for that application server to update its connection pool. So we kind of even try to take care of it even at the higher layers outside the Oracle RAC layers. For the database, what we do is when the actual time comes, when it says, all right, we're going to move, my instance is going to go down, we let the database decide that. We don't decide from the session side. We decide from the database. So let's say we can do it across transaction boundaries or not. For example, let's say you have an insert session application, OLTP application that says insert, update, delete, commit, exit, insert, update, delete, commit, exit. So if you do an insert and there is a the command to failover comes, the database will say, you know what, I'm still within the drain timeout, so I will wait for this session to do the commit and then resend it to the other side. That way, the application does not see a hiccup. Now think about it. Yes, if the instance had actually crashed, we can still send it over, and that thing and that session can continue where it left off. But this is lesser of a hiccup. So obviously this draining is something that we are done in 23C, and you can define it per database service. You can also find out what is your typical drain timeout in your AWR report. So you'd say, hey, how do I know what's a good number for me? Well, check the AWR. Now that in AWR, we provide you what is a good drain timeout. What that means is we give you, hey, in the last blah, blah time frame, most of your sessions were drained in these buckets, like 20 sessions drained in less than 1 second, 50 sessions took 1 to 5 seconds, and 10 sessions took 5 to 10 seconds. So then you can say, all right, my drain timeout is 10 seconds. Now, what that drain timeout tells you is that if we wait up to that 10-second timeout, if you finish draining before that, we are good. We don't even wait for 10 seconds. But if you wait up to 10 seconds because there's a session which is constantly doing work and not listening to these messages, after the drain timeout, we kill that session, failure to the other side, and continue where it left off. Now, obviously, this is much easier to implement for our database service. So now for our database cloud services, database can detect sessions that will not drain and can fail over. We proactively choose failover session based on rules, the rules being that you define for the drain timeout, right? And then the sessions that continue on with app continuity will fail over, will minimize the ungraceful session termination, will reduce the drain timeout and replay on failover. So all of these options try to make sure that the impact on your application during a planned maintenance is reduced. In this context, I have two features that I would like to talk about. This single server rolling database maintenance feature. So typically, as you see on the left-hand side, you see that Oracle RAC has been providing rolling patches for the longest time. You actually, simple, you apply it, basically go to first node, servctl relocate service, servctl stop instance, apply patch, servctl start instance, servctl relocate service back, and then go to second node and the third node and the fourth node and so on and so forth. This is good and works very good for my customers. But we have a lot of customers who are not using, as I would say, multi-node rack. You could actually have customers with single server, or they could have rack one node. Now, moving from rack one node across is a more of a impact to the application. So what we have done with single server rolling database update maintenance is you can use this feature to apply patches in a rolling fashion on a single server. How that works is obviously you need to make sure that you have enough CPU and memory, but basically you apply, I would say you do a out of place patching, which basically means you can have a whole ship home, I keep calling ship home, sorry, gold image on the other home, and then you start another instance on the same node and move sessions or drain sessions from the old one to the new one. This reduces the impact of the application because you don't have to go across the network and all that. You can also, in typical VMs, you can temporarily increase the CPUs and memory. And then once this operation is done, you can take it back. Oracle RAC on Oracle database is very well aware of how to automatically adjust its internal setting based on the number of CPUs and memory. And here's like a single instance. So now you have a way to consume rolling patching, which was pretty much in a multi-node rack to in a single server. So this is something that is amazing, which will reduce your downtime and also allow you to consume patches and RUs faster. Because the problem is, if you don't consume patches, and if there's a security issue or if there's a known bug or known issue, you are kind of subject to all those issues. So now having this makes it easier to consume patches so you're up to date and you're not having any known bugs which may cause you downtime to you. So in essence, what it works is it works the same. It's a choice customers have. You could do it on single server, or you can even do on rack. So why would you do on rack? Same reason, right? Because nowadays VMs are the most common way to deploy databases, and VMs are typically based on much larger physical hardware. You can easily go from 128 cores to 256 cores, no problem. So let's say you have this uh, feature, you temporarily increase the number of cores and memory, and within a rack instance, you actually start another rack instance on the same node. You move your sessions and then you stop the old one and you're done. The commands are very simple. So, you basically, deploy a new gold image and you say servctl modify database -d. This is my new home. And you pass that minus local rolling. And then when you're ready, and by the way, this operation can be done even before. So you could do this operation, say, on a Wednesday night or a Thursday morning, because this is just having deployed another database home. That's not a very intrusive operation. What is a little bit more involved is transferring. When you transfer it, what happens is the connections and all those things are transferred from the old instance to the new instance. So this is something that you can do one by one. So you can roll across instances, or you can roll within an instance and apply a patch. In this context, there's also one more feature I want to talk about, which is called as a two-stage rolling update. So what is a two-stage rolling update? So as much as we like to have all patches applied, in a rolling fashion, there are certain patches that change certain things in the memory, and therefore we cannot really apply it in a rolling fashion. So now with this feature, all those patches which were previously considered non-rolling can now be applied in a two-stage rolling fashion. Mind you, there could still be certain patches that may not be applied, and that depends on the developer. So now we have a automation in place where the developer has to answer a question saying, hey, can we use this feature? And most of the time, yes, but there could be some in the future that would say no. So that's a full disclosure I want to share. But how does this work? So let's say there's a patch that previously without this feature was supposed to be a non-rolling update. So therefore it was not added to any of the RUs. So now we can actually put it as part of the RU. How do we do that? Well, we have two phases. So, or two stages in a way. Stage one is basically apply the patch. So you apply the patch 1, 2, 3, 4. They are applied, but not enabled. So once you are done, you can enable the patch. So this is done using alter system enable RAC, two-stage rolling updates all. What that means is the patch is now active. So again, you don't have to do any moving of the application or sessions and services. Everything is working fine. You apply this, you're good. The good thing is we don't even force you to do the enable immediately. You can take the enable sometime later. So for example, you can apply the patch say on Wednesday and maybe decide that I'll enable it only on a Sunday or whatever you need to. So we give you a lot of choices, all that. All of these things that I talked about works with FPP. Now that's very important because now you're saying, how do I even remember these steps? OPatch this, apply minus of OPatch that. You can, if you have more than 2 or 3 database instances, you really want to take care or consider using FPP for patching so that makes it easier to manage it. And we make it even more easier for you to start with FPP. So if you think about it, the typical FPP mode is it is some entity that is sitting outside the databases and which can be used to patch all of your database deployments. Now with 23C, we give you something called as a local mode FPP. What is a local mode FPP? Is like you could actually use FPP to patch your one deployment, which is you could be having a 4-node rack or a 1-node rack or whatever. You can use FPP on that node. Why? Because once you standardize with one, when you have a second or third or fourth or fifth, it makes it much more easier to consider using FPP. So what is FPP local mode? Well, FPP local mode is, remember, FPP is supposed to be external entity because there are a lot of information it needs to store, and typically it's stored in a local database. Well, on a single server or one node or 2-node rack, you could actually put a lot of this information into some local store. So we have this local store of Apache Derby that we use, and then you can use the same commands, this RHPCTL move database, RHPCTL move GI home, and you can continue benefiting from this with a local mode option. Better HA with basically reduce the unplanned events. What that means is, remember I talked about that single server rolling database maintenance. You could actually use it on, as I told you, on a single server. That's Anil. What do you mean single server? I have to go and allocate VIPs. I have to go and allocate shared. No, you don't need to. We have this new option called as a general purpose cluster. A general purpose cluster is exactly like a regular cluster, except you don't need to pass scans and VIPs and all that. So that means you can actually start small. You can start with the general purpose cluster, set up your database, benefit from that single server rolling maintenance update, and when the time comes and you say, actually, I need another node, you just add VIPs and scan. ServCTL add scan, ServCTL add VIPs, boom. Your second node, third node, fourth node can start. So you can essentially convert easily. So that's something that is, the general purpose cluster is there for. We also have a lot of features for improved clusterware resiliency. What that means is typically things that would make the GI come down, we try to make sure that we don't even go down. So there is a lot of those self-corrections that we do with CVU. Cluster, well, it used to be called cluster verification utility. Now the new name is configuration verification utility. So it actually does a lot of verification. So if you apply a patch, and for some reason, some customers I've seen by mistake, they do Control-C or kill something. So some parts of the change more chmod operations or change, the permissions may not work. CVU can actually go and detect that. And in fact, if you give it the permission, we'll actually fix that for you. So we have a lot of those functionality included into CVU. I talked about there's a whole session I have done on 1 hour session on all this clusterware resiliency. So if you want, you can look at that. But this is one of the ideas that I've done. The second part is adjusting the OS kernel parameters. So if you apply a new OS update or patch, and then it changes some important thing that the database needs, then CVU can automatically change that and make it the recommended value. On Exadata, we make sure that we don't stall just because of one process being stuck. We have this expedited fencing on Exadata machine, so that now even if one process is stuck, we can escalate it from the process to the rack, and rack to the GI layer running in, can make sure that we can fence it working together with the Exadata components. And finally, on the right hand side, we have had this problem with rack, that if you have a 4-node rack and you lose the network, private network, everything comes down, all the 4 nodes come down. With this new feature, we call it last node standing. So if you, as shown in the example, node 1, 3, and 4 is down because the private network is having some issues, but node 2, we leave it up. The idea being that if somebody else tries to start up and the network is fixed, we can actually reconnect and again become a 4-node cluster. Fast start reconfiguration. So this is amazing. So anytime, obviously, we have all these features to prevent something going down. But if there's an eviction instance, we have to have a reconfiguration. What is reconfiguration? Reconfiguration is the time that we spend to make sure that the transactions that were committed are written and the uncommitted transactions are rolled back. So that takes time, especially if you think, as I said, the database is growing bigger and bigger and bigger, the SJ size are going bigger. So we kind of divide the buffer cache into what we call as, dirty blocks, which is dirty blocks is basically blocks which are, we know that has changed. Clean blocks, we know that there's no change, and dubious blocks. So now we start optimize the way that we work on those dirty blocks to make sure that we can mark it clean after making the changes. A lot of work has gone into this to make sure that this is about 6 times faster and about 3-4 times the recovery completes. It is a building block. It is of features, like for example, my favorite feature, Recovery Buddy, also contributes to this, and the way that we order how to go about working on those dirty blocks is important. So for example, if a dirty block is 10th in the queue to be recovered and somebody requests it, we fast track it and make sure that it's available. So we do a lot of these optimizations so that we can make sure that the work starts faster. Improved performance by optimizing resource usage, right? We have had this feature which we call as the database reliability framework. A database reliability framework tries to auto-tune the database based on the application usage. So for example, if the application is using, say, a lot more of particular kind of access patterns, then we can dynamically internally resize hash tables to ensure that the application can go as fast as we want. So you can look at all those events that we do, like in the $GCR underscore events and $GCR underscore metrics. We cover a lot of those things. And of course, we have a new name for our previously referred to as hang manager. We call it blocker resolver, just because the term hang is no longer very conducive in today's world. So blocker resolver, much better. Blocker resolver does the similar things that our previously hang manager used to do. We detect hangs, we detect deadlocks, and we do this in 23C about 5x faster, and we can resolve some of these things. Again, how does it help the application? Well, think of it. If your application is encountering a deadlock, it's going, something is stuck. Well, we automatically fix it so that the application can move along. Now, that doesn't solve the application, but we dump a lot of information to the DBA trace files so that the DBA can look at it and say, hey, to the application developer, can you fix this? The point being, there is no requirement to do manually go and fix this. Okay. In data guard environments, we automatically do things like, for example, if there's a temp file, we automatically create it on the standby database. And we also take care of corner cases, like if you're in a non-Oracle managed file system versus Oracle managed file system, we automatically create this depending on how you have set up, whether it's OMF or non-OMF. Availability, yeah. Well, scaling is we want to, Oracle is well known for scaling in all dimensions, right? You can scale from single instance, you can add more CPUs, you can add more memory, you can scale from single instance to horizontal scaling. We can do with the RAC, amazing, great. We can do with the globally distributed databases. You can shard them, and with active data guard, you can actually create what we call as read replicas. What is read replicas? So you could actually partition your application to do insert update deletes on the primary, and then reads or your queries can be offloaded to standby. This is an example of a customer who wanted to scale. So we kind of have these are phenomenal numbers. So this is basically something that is scaling up to 1 million transactions per second with a combination of technologies, including database sharding. Similarly, with our favorite customer, PayPal, we've been working with PayPal for a while, and we've been able to scale some of their most demanding workloads. Databases are doubling and tripling every 3 years, and then the number of transactions, it's not just the size, your executions and number of usages, how quickly you want to do things. All of these are dependent on the technologies like RAC and Active Data Guard. So amazing, combination of technologies that make sure our customers are successful. We have this feature called smart connection rebalancing, which helps in that. Remember, we're trying to reduce contention. So if you look at three, you obviously have hundreds and hundreds of custom sessions. If they are, we try to load balance them across the nodes. How do we load balance is very important. So if you have insert into sales being done by somebody and insert into employee done in some others, then wouldn't it make sense to, instead of spreading insert into sales into 3 different instances and insert into employee into 3 different instances, would it make sense to actually converge them into one, right? So this reduces what we call as inter-instance traffic, and also gives you the best of both. You're now rebalancing, but at the same time, we are doing smartly. And again, very simple. You just do servctl modify service minus the RLB goal smartcon, and then that's it. You're done. And then we will make sure we will internally track this at the buffer cache layer, and then we will send this up the event chain. We can send it via a fan event up to the application, up to the connection pool. So all of these things can be benefited without making any changes to your application. Okay. Exadata, we always keep doing more and more on Exadata, because, as I call it, Exadata is like the best platform for RAC, because we get what we call as low latency RDMA. So we have been going over it for a while, like with 19C to 21C. So 19C we started with doing undo block RDMA reads. So in-memory commit cache is a place where we keep transactions. So what that means is, when you do insert update deletes from multiple nodes, we want to make sure that the committed transactions are not running into each other. For example, if you have a sequence and both of these application try to insert using the next val, we want to make sure they don't use the same one. So we kind of have this in-memory commit cache for a synchronization. We are now using RDMA undo blocks. Now with 21C, we went one step further. If you get a grant, we can read ahead with that in less than 10 seconds than typically the UDP based what we call as messaging protocol. So once we get the global cache grant, we can go about 20 times faster. With 23C, we now further made this, we can actually remote read the transaction IDs via LMS. What that means is, remember, LMS works in block sizes of 8K and all that, right? So if you need one transaction ID, we need to read the block completely. Now, obviously, there are optimizations. We compress the block and all that. But with RDMA, we can just directly remote read the transaction ID without going through this whole compression mechanism. With 23C, we are even able to use RDMA to clean out what we call as the block cleanouts. So this is again another thing that we've done. Again, I'm going through this a little bit, just providing a summary, because I've already talked about a lot of this in the past. right? So this is how the in-memory commit cache is, just to give an example. So if you see on instance 1 to instance 2, instead of the foreground and the LMS sending like 4 messages, with this new optimization, we can actually have this with one message over RDMA. So now we have the wait event goes from 4x GCCR block 2A to just one single GC transaction table wait. Okay. Again, data guard environment, if you have a primary and you move your workload where you plan your workload, that you define it such that the global data services is aware, you can actually send your read insert or updates to the primary, and we call it the service read write. And then you can have actually a whole scale out farm to do all this queries for your databases. And so you can actually leverage Active Data Guard to do that. You can actually have some of these standbys in different. So for example, you can have them synchronous or asynchronous. So that way you get the best of everything. You can make sure you define it once and via the GDS. And if you create those services, the application can continue taking benefit of all of these. This is not just a pet, a laboratory experiment. We have actually had customers using it. As you can see, having just the primary and read write, we can actually get much more, what we call as benefit by having primary, with the read write, such that the read write is being redirected to primary, and the read only workload is, sent over to the standbys. Remember I talked about cache? Well, we have a new feature in 23C called True Cache, right? True Cache is essentially like a caching layer which you can put right in front of the application. And True Cache can, basically, it's like you set it once and it will automatically take care of, refreshing itself. So basically, it's automatically managed. So conceptually, if you want to think about True Cache, it's basically a diskless active data guard. What does a diskless active data guard mean? Remember, you have in a actual active data guard, you send the changes, this return to the disk and all that. Well, we basically send the changes and the cache is updated. Why is that important? Because if the cache crashes for something, the session would actually come to the database and use it. And if you have multiple caches, we can actually fail over. Same thing. Remember the failure scenarios that we have? We continue to have that across for our cache layer also. So this is amazing new technology that you can use, especially for all those applications which are very, very latency sensitive. With app continuity, we do a lot more things in 23C. We have this, improvements in performance. For example, if you have a workload like select from a large table for a where clause, and then you do while, for each row do something, and if there's a crash, we kind of have this feature where we resume the cursor. So without this feature, we'll have to recreate this cursor and then continue on from the start. We can actually resume this cursor. Reset state is another thing. Applications use what we call as temporary tables, PLSQL globals, and all that. So starting with 21C itself, what we have further improved that in 23C, the database will reset the state at the end of the request. That means that it's much more easier for app continuity to replay those if there is a failure. And then driver support, we continue to improve the driver support for ODP.NET and managed clients, unmanaged clients, we have desupported it. Well, we have deprecated it, and we plan to do desupport in future releases. And on the right-hand side, instead of having these multiple drivers, we have a consolidated driver. So now you have this consolidated driver, so you don't need to swap in and swap out files. So if there is a problem and we say, hey, can you move your JDBC jar file to the debug one and all that? No, you don't need to do that. One file, everything is there in that. And then obviously with 23C, we have all these great numbers, 40% faster failover for selects. Remember that feature I talked about, resumable cursors, great. We also have 50% lesser impact on the database CPU, and then about 55% lower cost on the client. Sequences, we have with RAC, we have improved the performance of sequences. And I've talked about this in a lot more detail, but the net is, if you are using ordered sequences and you're using 23C Oracle RAC, you should see significant performance improvement. If the sequence is accessed in one node, you would see a performance improvement by like 40% reduction in throughput and about 3x improvement. And if you're doing it on all nodes, for example, in my 8-node cluster, I found a performance improvement by 2x time reduction in wait times and about 2x time reduction increase in throughput. On the right-hand side, you say, hey, my application uses DBMS pipe. Well, if you're using a DBMS pipe and you want to use Oracle RAC and it's on the cloud, now DBMS pipe can work on the Oracle cloud, because now, remember, the pipe used to be a what we call as an entity on the file system or something. Now we can enhance that we have enhanced that to use like what we call as the OCI object store. Now, this is very important because now you can use DBMS pipe to actually pass messages or exchange messages between an OLTP Exadata database or OLTP autonomous to an ADW, which is an autonomous data warehouse. So this is something that allows you to seamlessly consume our technologies and get the best of what you want to achieve. With that, I think I'm 4 minutes over. Sorry about that, but I just wanted to make sure that, again, our goal with 23C is to provide you easier and faster access to all different technology options, which are the best part is they all work together, and make sure that all of these technologies efficiently support more and more workloads. With that, pretty much this is the last slide. I am sorry I had to go through it. I took extra 5 minutes. I apologize for that, but I hope my colleagues have been up to date or keeping up with the chats and Q&A. If there's any good question that you need me to read out, I can always do. If you've already answered, I would like to thank you.
Yeah, do we have time for a couple of questions, Osama?
Sure, definitely.
Yes, we do.
So there have been a lot of questions about the release date, 23C release date,
yes,
as well as documentation. I guess the old documentation is about RAC and how to migrate from older versions to RAC will be available on the online docs. But is there any paper or any place you suggest to people to look at?
Yes. So technically, the release date is, what we call as the first half of calendar year 2024. So if you look at first half, typically first half is something before June. We are almost end of April, so you can do the math. So that's the best hint I can give you on that. Unfortunately, because of legal and other reasons, I can't just tell you like, yeah, it'll be XYZ date. So, but that's a good hint. And since it's only 2 months left, you get a good idea. The good part is, if you want to play with this, I keep telling, join the beta program. You can actually have this, and a lot of these features are feedback from our beta customers. So shout out, thank you for providing us the feedback. And for others who have not done, please do join us even in future, because this is really something that we can help out each other.
Right. Okay, another thing, if you allow me, this a really detailed question about the ASM Live version 3. Are there any news on that? Because we couldn't figure it out, right?
Right. So yeah, ASM Lib is an interesting question because so the whole 2-minute history of that is we had ASM Lib. ASM Lib is a component that helps us provide persistent devices, right, for Oracle databases. It's been out for a while. It works great. But as the kernel keeps improving and changing, we found out that a lot more of it we cannot do, or it's much better to do in userland. So we completely re-architected ASM Lib so that it doesn't need to run in what I call as privileged mode. It can run userland. The changes are done. We are actually working very closely with 1 or 2 customers to make sure that, because it's a major change, we're actually working very close with customers on that. If you have a very interesting use case, again, anil.nair@oracle.com, let me know. I can work with you. But ASM Lib is out there. It should be out very, very shortly, I would say. And again, you can use it with older like 19C databases and all that. But ASM Lib, that's the story about it. Hope that was clear enough.
Okay, well, there's another bunch of questions, but I guess that we are not really enough time, right? That's That's good.
Right. Yeah,
Thank you.
sorry about that. Apologies. And as I said, any of those questions you want me to answer, feel free to put that on social media, reach out to us. You have all the ways to reach out to us. Don't feel that we are not answering your question. It's just a matter of time. We'll definitely, if not, cover it in one of the future seminars. That's all I have. Thank you so much. Osama, you want to go with the lab?
Anil, just a question from my side. So we have recommended 5 live labs to the attendees to go through today, and these live labs haven't accounted for 23C updates yet. So any idea if new labs will be available, or if these live labs will be updated later on?
Yes. And all of those labs will be updated soon, right? That's the thing. See, because this is an external entity, we can't actually do the live labs before the release. But yes, once the release is out, all of those things that we talked about will be updated with the latest and greatest.
Okay, good. So at least they can go through the ones we provided them with in case they are not familiar with these topics. And hopefully once 23C updates make it through, then they can actually look at the new live labs or the new versions of the live labs once they become available.
Right.
Okay, so I guess there are no other questions, right? Or is there any still, Jesus, before we close?
Yeah, well, still we have, if we have a couple of minutes. So there's a question on the actual packaging of RAC and the grid infrastructure. Are we going to receive the same as usual, the grid infrastructure and DB Home and separate, let's say, installs? And
Yes.
the second is this grid in read mode? Could it be in read mode, read-only mode?
Well, let me answer this one by one, right? So yes, we will continue to use what we call as our gold image based deployment. So GI will have its own image. Database will have its own image. So yes, you will have to have 2 of them separately. The read-only home or the Oracle read-only home part is something that we did not see much usage with customers. If you are a big user, let me know, as I keep saying. So we haven't done much in that area. Okay, so that hopefully answers the question.
Okay, good. And is this a specific question on OpenShift? Is RAC will be supported on OpenShift? Any news here?
Well, OpenStack, yes. OpenShift, well, it depends. So again, these are all very high level things. It's kind of like saying, hey, is our database supported on Linux? Well, yes, certain combinations of versions and kernels of Linux is supported. So that is a very high level question, I would say. If you send specifics, I can check it out and make sure that its support is there or not. Remember, all the time when you're having these kind of questions, the configuration verification utility ensures that our requirements are met, as in what are the things we need to get this going. So that is always the first step. A lot of these containerized deployments do not have that. The other part is, remember, some things are absolutely wrong. For example, if you do a 2-node rack on a one host, 2 VMs, one host, that's a really bad idea, because every time you need to patch the firmware on the host, everything is down. So those are not even recommended or supported. Obviously, we can't figure that out, because when you're running on the VM, we don't know. But we have explicitly made it clear in many documentations that that's the case. So what I'm trying to tell is, if you take all of these together, and if your kernel and all those other things are then maybe yes. Again, it depends on the specifics. If you have a very good use case, again, reach out to me. I can always help answer that.
Okay, thank you, Anil. I guess the rest of the question is just to have the release out or the beta, as you mentioned, and start trying out, right? Because this is, I guess, the next steps. Thank you, Anil, for your answers.
Great.
Okay,
Sure.
yeah. So thanks, Neil, for the presentation today, and thanks, Jesus and Stefan, for taking care of the questions. So I'd like to thank everyone for joining us today. I hope that you found today's session very informative. And see you again next month, and goodbye.
Thank you. Bye-bye.